Hi, and welcome to Tierra Linda's Science Night presentation on electricity and magnetism, two of my favorite subjects. So I'm going to start talking a little bit about magnets. Now these are some little round donut magnets. You guys have probably played with magnets before, and you know that they kind of stick to each other, and you also know that they kind of repel away from each other. So that's kind of cool. And then you probably also know from playing with magnets that they stick to some things and don't stick to other things. Like, do they stick to wood? No, they don't stick to wood. How about rocks? Do they stick to rocks? Nope, don't stick to rocks. Pencil, doesn't stick to that either. What about a paper clip? Yeah, picks up a paper clip. That's pretty cool. Does it stick to all kinds of metal? Well, here's a copper penny. Doesn't stick to that one. Here's a dime. Doesn't stick to that. Here's a steel washer. Wow, it sticks to that one. So now we know magnets only stick to some kinds of metal. Steel in particular they'll stick to. Here's a piece of aluminum. Doesn't stick to that either. So what do you know? It only sticks to the steel. Now I have a special kind of magnet here called a compass. You might have played with them. They're used to find north and south, and they actually work because magnets stick to each other. And so this little magnet is lined up with the North Pole on the Earth. This compass can also be a magnet detector. If I bring my magnet nearby, it's much stronger than the Earth, and it'll make that compass move. So a compass is a magnet detector. Now I want to show you something else really cool about magnetism. What I have here is a piece of wire. Now, does anybody think a piece of wire is a magnet? Let's put it down by the compass and see. Huh. No, that piece of wire isn't a magnet. Now what happens if I take this piece of wire and I hook it to a battery? Let's try that one. Look at that, the compass moves. So when I put electricity through this wire, the wire becomes a magnet. That's pretty cool. Electricity is a magnet. But this magnet isn't very strong. Do you think I can pick anything up with this magnet? Let's get my piece of metal here and we'll hook up the electricity. Nah, it didn't pick it up. This wire from this battery doesn't make a very strong magnet. So how could we make a more strong magnet with this little bit of electricity? Well, look at what I have here. You can see in here, it looks like a little bit of orange stuff. This is actually hundreds of little tiny wires all lined up together. So instead of one wire, I now have several hundred wires. So what do you think several hundred wires are going to do? They should be several hundred times stronger than this one wire. So let's try that one. I've got my metal washer here, and I've got my wires, and I'm going to hook them up and see what happens. Let's stick the wires together. Look at that. It can pick up the washer, and when I disconnect the wire, it drops off. Try that again. Disconnect the wire, it drops off. So this is what's called an electromagnet. I take this wire and several hundred of his buddies all together, put some electricity through it, and now it's a magnet strong enough to pick up a piece of metal. Alright, so let's try an even bigger magnet and see what happens. Does that sound cool? If this is cool, a bigger one's going to be even cooler. So what I have here is a really monster electromagnet. This is copper wires wound around, and this is a steel bolt. So I'm going to put that down here, and instead of this little battery, I'm going to use a big battery. So let's hook this up, and we're going to see what happens. I'm going to clip that on, and I have my piece of metal here, my steel washer, and I'm going to hook this up. Whoa, that's a powerful magnet now. Pretty cool. Now, what I have here is a piece of aluminum. Remember, aluminum doesn't work with magnets. I have my magnets here. They can pick up the steel, but they don't pick up aluminum. Let's try it with the electromagnet, see if electromagnets are any different. Turn on my magnet. Doesn't stick. Now, I'm going to try something a little bit different. I'm going to take this piece of aluminum and I'm going to put it on top of the magnet. Now, aluminum doesn't stick to magnets, so when I turn this magnet on, is anything going to happen? Everybody say, no, nothing's going to happen, right? Because we know magnets don't work on aluminum. So here we go. We're going to turn it on. Did you see something? Turn it on again. Did you see something there? Do it again. It moved. How's that happening? Aluminum doesn't stick to magnets. We know that. What happens if I turn it on and off really fast? That's pretty weird. When I turn the magnet on and off, the aluminum moves. But if I just hold it, nothing happens. That's pretty amazing. A magnetic field that turns on and off can actually work on aluminum. A magnetic field that always stays on doesn't do anything with aluminum. But if I turn it on and off, it works on aluminum. That's pretty cool. So I actually have magnetic aluminum here. Now we're going to try something a little bit different. Did you know that the electricity in your house isn't like batteries? The electricity from a battery just goes all the time. But the electricity that comes out of the wall, it goes on and off really fast. So what I have here is a transformer that's plugged into the wall, and I'm going to plug my magnet into it. So let's ramp it up, get a little bit more power, and plug this thing into the wall. So let's turn this on and see what happens. Look at that. Is that pretty amazing? My little aluminum is floating in the air. It's levitating on this magnetic field, even though aluminum is non-magnetic. Alright, so that was pretty cool. What do you think happens if I crank this all the way up? You guys ready to see? Here we go. Let's crank it up all the way up. And this one goes to 11. Here we go. Pretty cool, huh? You want to see that again? All the way, now 14, here we go. Boom! That is pretty cool. We've got ourselves an aluminum launcher here. And this is all from a magnet and non-magnetic aluminum. Pretty cool. And that's because the magnetic field is changing, and a changing magnetic field induces electricity in the aluminum, and then that electricity in the aluminum makes it magnetic. So this is electromagnetic induction. It makes a new magnet. Now, induction doesn't only work with electricity. Induction can also work with permanent magnets. So what I have here is a very, very strong permanent magnet. These magnets over here were little round ones. This one's a rectangle. I'm going to put it down here on the table so you can see just how powerful it is. Watch that piece of steel. And it slammed, it pinched my finger. This is a super powerful magnet. And then over here I have a big chunk of aluminum. Now you remember, aluminum isn't magnetic, so this magnet won't stick to it. I'm going to hold it up, I'm going to stick it. It doesn't stick. But if you were over here and you put it on top of this and you slid it back and forth, you'd feel something really weird. It feels kind of sticky, almost like the magnet is floating in honey when I do this. That's a really strange feeling. It's kind of a viscous feeling. That's because when the magnet moves, it's a changing magnetic field, and it makes electricity flow in the aluminum plate. And that electricity is a magnet that interacts with this one. So it's pretty weird. Copper is the same way. The magnet doesn't stick to it, but since it's a conductor, I can feel some squishiness here. So let me show you something pretty cool. I have this piece of aluminum. Remember, it's non-magnetic. I'm going to drop it through this pipe. It's about what you thought would happen, huh? Now I'm going to take this magnet and I'm going to drop it through the pipe. Whoa! What happened there? That was pretty cool. Let's try that again. Aluminum, drop it through the pipe. Wham! Magnet, drop it through the pipe. That's pretty cool. What do you think's happening there? It's that sticky feeling. When you slide it and it feels sticky here, well, that sticky's happening. It's viscous drag. All the way down, the magnet's going really slow. Now, don't you wish you could see that? That'd be pretty cool. Well, you can. I'm going to set up my two pieces of aluminum here, and then we're going to drop the magnet between them. So line up right so you can look right through here, and I'm going to drop the magnet down inside there. Did you see that? Let's try that again. We're going to drop it again. See that? It falls really slow. In fact, it tumble sometimes. If I drop it just right, it'll actually float down in there. Is that really amazing? So here it is, one more time. Anti-gravity with electromagnet induction. So that's pretty cool. So that's my presentation on electricity and magnetism and induced magnetism for Tierra Linda's Science Night. Thanks for watching.